Every decision you make creates a different version of reality. This is the core of the multiverse hypothesis, a serious scientific idea proposing our universe is just one of countless others. By the end of this journey, you will understand the compelling evidence suggesting infinite worlds may truly exist alongside our own. We will explore what quantum experiments reveal about branching timelines, how the Big Bang might have spawned a cosmic sea of bubbles, and whether you have countless versions of yourself living different lives. The answers will challenge everything you think you know about existence. What does the possibility of endless realities make you feel about your own choices? Our universe feels vast and complete, a grand cosmic theater containing everything we will ever see or touch. But this entire magnificent expanse, from the most distant galaxies to the very fabric of space itself, might be just a single room in an infinite mansion. This is the fundamental shift in perspective the multiverse demands. We are not talking about distant galaxies within our own cosmos. We are talking about entirely separate realms of existence, each potentially as vast and complex as our own, yet forever beyond our reach. Think of it this way: our observable universe is like one page in an endless book. Every other page tells a different story, governed by different rules. Some pages might describe realities where gravity is stronger, where stars never formed, or where time flows in a different direction. This idea, the multiverse, is not one single scientific theory. It is a consequence, a stunning implication that emerges from several of our most successful attempts to understand reality. Quantum mechanics, the study of the impossibly small, suggests one kind of multiverse. Cosmology, the study of the impossibly large, suggests another. String theory, an attempt to unite them all, suggests yet another. Each path leads to the same breathtaking vista, a cosmos of cosmoses. To even begin our exploration, we must make a clear distinction. Our universe is everything that sprang from our own beginning, all the space, time, matter, and energy that is connected to us, even if the light from its farthest reaches has not had time to arrive. The multiverse is the hypothetical collection of all such universes, a meta-reality where ours is just one member. This conceptual leap from a solitary universe to a community of universes is the essential first step. It prepares us to ask the most profound questions. If other realms exist, how did they come to be, and what incredible variety might they contain? The desire to see beyond the horizon of our own world is woven into the very fabric of human thought. Long before telescopes peered into deep space, philosophers gazed into the void of possibility. In ancient Greece, thinkers like Democritus, who envisioned a universe of indivisible atoms, also dared to propose the existence of infinite worlds drifting in an infinite void. For them, it was a logical extension of their ideas about matter and emptiness. If atoms could combine in endless ways, why not in endless places, creating realities beyond our own? This was not science as we know it, but a profound philosophical leap, a first glimpse of a cosmos far grander than a single stage. For centuries, the concept remained in the realm of metaphysics and imagination. Then, in the middle of the 20th century, a brilliant and controversial young physicist named Hugh Everett III forced the idea into the harsh light of scientific scrutiny. He was grappling with the bizarre puzzles of quantum mechanics, where particles seem to exist in multiple states at once until observed. The prevailing explanation felt unsatisfying to Everett. So he proposed a radical alternative, his many worlds interpretation. In this view, every possible outcome of a quantum event does indeed happen, but each plays out in a newly branched parallel reality. The universe does not choose one path, it takes them all. Everett was not suggesting we travel to these worlds. He was stating mathematically that they must exist as a consequence of the equations. His work was initially met with skepticism, but it planted a seed, transforming the multiverse from poetic speculation into a legitimate, if startling, scientific proposition. The idea gained even more traction decades later with the work of cosmologists like Andre Linde. His development of the theory of eternal inflation provided a powerful new mechanism for generating not just one universe, but a limitless number. Imagine the Big Bang not as a single explosive event, but as a forever boiling pot of spacetime. In this model, our entire cosmos is just one bubble that formed and cooled in an eternally expanding sea of inflationary energy. And if one bubble can form, an infinite number can, each with its own unique physical laws, a process that never begins and never ends. Linde's work gave the multiverse a cosmological engine, a plausible story for how such a breathtaking plurality could come to be. This journey, from the philosophical musings of antiquity to the hard equations of modern physics, reveals a crucial truth about our quest to understand reality. Each time we push the boundaries of knowledge, the universe seems to answer with even greater mystery and scale. We moved from a single world to a solar system, to a galaxy, to a universe expanding in all directions. Now, our most successful theories gently, persistently, point toward a horizon beyond that universe. The multiverse is no longer just a thought experiment. It is a serious frontier of inquiry, a direct implication of our attempts to explain the quantum and the cosmic. It asks us to consider that every limit we have ever discovered might simply be the boundary of our local reality. The quantum world operates by a different set of rules entirely. To understand the first pillar of the multiverse, we must shrink our perspective down to the realm of the impossibly small, where common sense breaks down and reality itself becomes fluid. The most famous window into this strangeness is the double-slit experiment. Consider a single particle like an electron, aimed at a barrier with two narrow openings. Our everyday logic suggests it should pass through one opening or the other and strike a detector screen behind it, leaving a single mark, but that is not what we find. Over time, the particle creates an interference pattern, a series of stripes, as if it traveled through both openings at once like a wave. This is the heart of superposition, the idea that a quantum object can exist in a blend of multiple states or locations simultaneously. This leads to a famous puzzle in measurement. The moment an attempt is made to observe which path the electron takes, the interference pattern vanishes. The particle then behaves as if it picked one definite path. For a long time, a common explanation was that the act of observation somehow collapsed this wave of possibilities into one concrete reality. But to physicist Hugh Everett, this proposed collapse felt like an unnecessary complication. He offered a breathtakingly simple alternative, known as the many worlds interpretation. Everett suggested the mathematics should be taken at face value. The superposition never collapses. Instead, every single possible outcome contained within that wave actually occurs. The universe itself branches at that moment, creating parallel timelines where each possibility plays out. In one branch, the electron is recorded going through the left opening. In another, equally real branch, it is recorded going through the right. Both versions of the observer are convinced their outcome is the only one. Think of it like a choose-your-own adventure book. At the bottom of a page, you are given a choice: turn to page 47 or page 63. In our classical view of reality, you pick one, and the other story path ceases to exist. In Everett's quantum view, the book does not force a single choice. Instead, the book splits into two copies at that moment. In one copy, the reader turns to page 47 and continues that story. In the other, an identical reader turns to page 63 and lives out that narrative. Both stories are equally real, they just can no longer interact. This approach solves the measurement puzzle elegantly by eliminating the need for a special collapse rule. There is no mysterious observer effect. Probability simply reflects our experience of being one specific version of ourselves, unaware of the other branches where different outcomes unfolded. It suggests every quantum event, every random atomic process, every possible interaction gives rise to new universes. The implications for how we think about ourselves are profound. This interpretation remains a topic of discussion, but it provides a powerful and mathematically consistent foundation for one type of multiverse, a vast and ever-branching tree of realities growing from the quantum roots of our world. If the quantum realm suggests a branching tree of possibilities, cosmology offers a vision of a bubbling cosmic sea. The second pillar of the multiverse hypothesis takes us back to the very first moments of existence, to a theory that reshaped our understanding of the Big Bang itself. It is called cosmic inflation. In the tiniest fraction of a second after the beginning, our entire observable universe, everything we can see, is thought to have expanded faster than the speed of light. This was not an explosion into space, but a rapid stretching of space itself, smoothing and flattening the cosmos in a blink. This idea, pioneered by physicist Alan Guth, elegantly explains many features of our universe that the standard model could not. But the most profound implication lies in what might have happened next. Inflation, according to some models, may not have been a single event that started and stopped. It could be eternal. Picture a pot of water coming to a boil. Bubbles form, expand, and drift apart in the steaming water. Now, imagine that the water itself represents a strange, high-energy state of space that drives inflation. Our entire universe is just one of those bubbles, a region where inflation locally ended, allowing matter to form and stars to ignite. But outside our bubble, the inflationary process never stops. It continues forever, endlessly spawning new bubble universes in an ever-growing cosmic foam. This is the theory of eternal inflation, a self-replicating engine for creating a multiverse. Each of these pocket universes is causally disconnected from the others, forever separated by oceans of inflating space that expand faster than any signal could ever cross. They are not branches of a single timeline, but entirely separate cosmic islands, born from the same eternal process. Within this breathtaking landscape, a crucial detail emerges. The transition that ends inflation inside a bubble, the shift from that driving energy to the stable laws we know, is triggered by random quantum fluctuations. Think of it like the final spin of a cosmic wheel as each bubble forms. These tiny, random variations mean that the properties of each new universe could be determined by chance. The fundamental constants, the strengths of forces, even the number of spatial dimensions, might be randomly selected as each pocket universe cools. In this view, our universe is not special or designed. It is simply one outcome in an endless process of creation. We find ourselves in a universe with stable atoms, long-lived stars, and conditions suitable for life, not because such a setup was intended, but because in an infinite array of possibilities, some bubbles will inevitably have the right parameters. This offers a potential answer to one of physics' greatest mysteries, the fine-tuning problem. The fact that our universe seems improbably perfect for life might not require a fine-tuner. It might simply be a statistical inevitability in a multiverse where every possible set of laws is realized somewhere. Our cosmic address, then, is not just a random point in space, but a random bubble in an infinite and eternal froth of realities, each with its own unique and unchangeable rules of physics. The quest for a single theory that explains everything has led physicists down a path of breathtaking mathematical beauty and staggering complexity. This is the realm of string theory, and it offers a third, profoundly different vision of the multiverse. While quantum branching deals with alternate histories and eternal inflation spawns cosmic bubbles, string theory suggests a multiverse of fundamentally different realities, each built from entirely distinct blueprints. The core idea replaces the point-like particles of traditional physics with unimaginably tiny, vibrating loops of energy or strings. The way a string vibrates, its frequency and mode, determines what kind of particle it manifests as, from a quark to a photon. To make the mathematics of these vibrations work consistently, the theory requires more dimensions than the 3 of space and 1 of time we experience. It proposes a total of 10 or 11 dimensions, with the extra ones curled up and hidden at a scale far smaller than an atom. This is where the concept of the landscape emerges. The specific way these extra dimensions curl and fold is not dictated by a single, unique solution. Instead, the equations of string theory yield an astronomical number of possible stable configurations, each representing a different possible foundational state for spacetime. Physicists estimate this number could be around 10 to the power of 500. That is a 1 followed by 500 zeros, a figure so vast it dwarfs the number of atoms in our observable universe. Each of these possible configurations corresponds to a cosmos with its own unique set of physical laws, constants, and even numbers of observable dimensions. To visualize this, think of an endless, rugged mountain range. Each valley in this cosmic terrain represents one of those stable configurations, a possible universe where the forces and particles are settled into a specific, self-consistent arrangement. Our universe, with its particular strength of gravity and its 4 familiar dimensions, is just one valley among an inconceivable multitude. Other valleys might harbor realities with 5 forces of nature, or where electromagnetism is 1,000 times stronger, or where chemistry as we know it is impossible. This landscape multiverse is not about branching from a shared past or bubbling from a shared sea. It is a static, eternal array of every mathematically possible reality that string theory allows. The profound challenge and the source of much discussion is that these other valleys are permanently out of reach. We cannot travel to them, nor can we observe them, because to do so would require fundamentally altering the very fabric of our local reality. This makes the string theory landscape perhaps the most speculative pillar of the multiverse hypothesis, residing at the very edge of testable science. Yet its power lies in its potential to address the ultimate question of why our universe has the rules it does. In this view, there is no deeper reason. Our cosmic valley was simply one possibility that became actual, perhaps through a random quantum jump during the inflationary process. We are not in a special or designed universe, we are in a possible one. This shifts the goal of fundamental physics from seeking a single, unique theory of everything to mapping the vast landscape of everything that could possibly be. It suggests that the ultimate laws of nature are not laws at all, but a menu of cosmic options, and our existence is a testament to one particular habitable selection. Georg Cantor, a mathematician of the late 19th century, was captivated by the infinite. While others used infinity as a vague notion of endlessness, Cantor sought to understand it with rigorous logic. His revolutionary insight was that not all infinities are the same. He demonstrated that the infinite set of whole numbers 1, 2, 3, and so on is distinct from the infinite set of real numbers, which includes all the decimals between any 2 points. In essence, he proved some infinite collections are larger than others, a concept so challenging to the mathematical thinking of his time that it shaped his personal and professional journey. Cantor's work provides a crucial framework, showing that infinity is not a single idea but a structured, layered concept mathematics can explore with precision. But mathematics is a language of pure logic, a game played with consistent rules. The pressing question for physics is whether the universe, in all its rich, concrete reality, actually follows that same game. Can physical existence truly be without limit, or does infinity represent a frontier where our theories reach their current edge? This debate touches the very heart of the scientific method. Science advances through testable predictions and observations. We formulate a hypothesis, use it to predict an outcome, and then check if nature agrees. But what happens when a theory suggests not just other cosmic domains, but a limitless number of them? If every possible event occurs somewhere in a greater landscape, then the theory technically encompasses everything. And a theory that encompasses everything risks explaining nothing at all in a specific, testable way. Some observers note this could place such ideas from the realm of empirical science into the domain of metaphysics, a fascinating philosophical concept, but one potentially beyond the reach of experiment. It raises a thoughtful question: could accepting a boundless cosmic landscape suggest a step away from the core mission of physics, which is to explain the specific, observable world we actually call home? Supporters address this by pointing to indirect evidence. We do not need to visit another domain to find support for the ideas that imply their existence. The precise patterns in the cosmic microwave background radiation, the afterglow of the Big Bang, are a key prediction of cosmic inflation. The confirmed existence of gravitational waves, ripples in spacetime, also supports inflationary models. If our best explanation for the features of our own universe is a theory that naturally and unavoidably generates a vast cosmic landscape, then we must consider that implication seriously. This broader view, in this perspective, is not the hypothesis itself, it is a consequence of the hypothesis. We test the root theory like inflation, and if it passes every observational check we can devise, we must contemplate the profound reality it describes, even if we can never perceive all its realms directly. The relationship between mathematical elegance and physical reality is a long-standing story in physics. Infinity is a tool that works brilliantly in our equations, from describing the concentration at a black hole's heart to the smooth fabric of an idealized universe. But whenever infinity appears as a physical answer, it often signals a missing piece, a place where our current understanding reaches its limit. The idea of a limitless cosmic landscape invites us to consider this relationship on the grandest possible scale. Is it the ultimate answer, a sign that reality truly is without bounds in every sense, or is it a guidepost, a magnificent mathematical hint pointing toward a deeper, more complete truth we have yet to discover? The search for that answer may well define the next chapter of our cosmic story. The precise balance of our universe feels less like a random accident and more like a carefully set stage. Tweak the strength of gravity by a fraction or alter the charge of an electron, and the cosmic drama collapses before it can even begin. Stars would not ignite, atoms would not bond, and life as we know it would be an impossibility. This is the fine-tuning problem, a profound mystery that asks why the fundamental constants of nature appear to be exquisitely calibrated for our existence. It is as if the universe won a cosmic lottery against impossible odds. The multiverse hypothesis offers a breathtakingly simple resolution to this puzzle. In an infinite landscape of realities where every possible set of physical laws is played out, it is no longer a surprise that we find ourselves in a universe that allows us to be here to ponder it. We are not the beneficiaries of a miraculous coincidence, but the inevitable inhabitants of a habitable corner in a vast, varied cosmic terrain. Consider the cosmological constant, a number that represents the energy density of empty space, often called dark energy. Its measured value is astonishingly small, yet if it were even slightly larger, the repulsive force it generates would have torn the universe apart before galaxies could ever form. If it were slightly more negative, the universe would have recollapsed upon itself almost immediately. The value we observe permits just the right expansion rate for structure to slowly coalesce over billions of years. Another example lies in the nuclear forces that bind atomic nuclei. The strength of the strong nuclear force is precisely tuned. If it were a few percent weaker, simple hydrogen would be the only element, and the complex chemistry of life would have no building blocks. If it were slightly stronger, all hydrogen would have fused into heavier elements in the early universe, leaving no fuel for long-lived stars like our Sun. The mass of the proton relative to the neutron is another delicate balance. A small shift would destabilize the atoms that make up everything we see. Faced with such a precise and interconnected set of requirements, one might conclude the universe was designed for life. The multiverse provides a different kind of answer, one rooted in probability rather than purpose. This is known as the anthropic principle, a logical filter of observation. We can only observe a universe compatible with our existence. In a single, solitary cosmos, this fine-tuning demands a special explanation. But in a multiverse, it becomes a statistical certainty. Imagine walking into a vast, randomly assembled library containing every book that has ever been written or could be written. You pull a single volume off the shelf and open it. To your amazement, it is a perfectly coherent novel written in your native language, telling a story you find deeply meaningful. In a library of one book, this would be a miracle. In a library of all possible books, it is simply the result of your selective observation. You were bound to eventually find a book you could read and understand. Similarly, in a cosmic ensemble where the laws of physics are shuffled like a deck of cards in every new universe, some combinations will inevitably produce stable atoms, long-lived stars, and planets. Observers will only ever arise in those rare, hospitable pockets. Our universe is not fine-tuned, it is self-selected by the very fact of our presence within it. This perspective transforms a question of why into a question of where. We are not asking why the universe is perfect for us, but rather, what must the broader cosmos be like for at least one such universe to naturally occur? The multiverse answer is one of breathtaking scale and variety, a reality so prolific that every potential outcome finds a home somewhere. It suggests that the peculiar suitability of our local laws is not a clue to a deeper design, but a signature of our address within a far vaster and more impersonal meta-reality. The fine-tuning problem, therefore, becomes less a puzzle to be solved by a unique theory of our universe, and more a compelling clue pointing toward the existence of a grander cosmic landscape beyond our view. Such a profound shift in our cosmic perspective cannot be accepted without rigorous challenge. The multiverse hypothesis stands at a fascinating and contentious frontier, one where the very definition of science is being tested. For every visionary who sees it as the inevitable next step, there is a respected critic who views it as a step too far, a retreat from the hard-won principles of empirical inquiry. Among the most vocal skeptics are physicists like Paul Steinhardt and David Gross, who argue that the multiverse, in its current form, may not be science at all, but rather a philosophical speculation dressed in mathematical language. Their central concern is one of testability. A core pillar of the scientific method is falsifiability, the idea that a theory must make predictions that could, in principle, be proven wrong by observation or experiment. If a theory is structured in such a way that no conceivable observation could ever contradict it, then it resides outside the realm of science. Critics contend that the multiverse, especially versions like the string theory landscape, risks falling into this category. If every possible physical outcome occurs in some universe, then any observation we make in our own universe is guaranteed to fit the theory. It becomes what some have called a theory of anything, capable of explaining everything after the fact but predicting nothing specific in advance. This, they warn, could lead to a stagnation in fundamental physics, where the difficult but essential work of finding a unique, predictive theory for our single universe is abandoned in favor of a comfortable but ultimately untestable cosmic democracy. There is also a concern about the explanatory power of the idea. Saying that our universe's laws are one possibility in an infinite landscape may feel like an answer, but does it truly explain why our particular set of laws exists here and now? Some argue it merely shifts the question one step back from why this universe to why this multiverse. Engaging with these counterpoints is not a weakness of the idea, but a vital part of its scientific story. Extraordinary claims do indeed require extraordinary evidence, and the honest pursuit of that evidence is what separates science from belief. The response from multiverse proponents is not to dismiss these criticisms, but to refine them. They argue we are not testing the multiverse directly. We are testing the underlying theories that imply its existence, like inflation or specific interpretations of quantum mechanics. If those root theories continue to pass every observational test we can devise, from the detailed structure of the cosmic microwave background to the behavior of particles in giant colliders, then we must take their implications seriously, even if the ultimate implications are currently beyond our direct view. Furthermore, they suggest that indirect evidence may one day be found, subtle patterns in the cosmic microwave background, perhaps imprints from collisions with other bubble universes in the distant past, or peculiar quantum correlations that only make sense in a branching reality, could provide observational hooks. The debate itself is a sign of a healthy, vibrant field grappling with its most profound questions. It reminds us that science advances not just through confirmation, but through contention, through the constant pressure to prove and improve. Whether the multiverse is a temporary placeholder on the road to a deeper truth, or the final, shocking vista of reality itself, is a question that will be decided not by rhetoric, but by the relentless, collective effort to understand our place in the cosmos. The possibility of a boundless cosmic landscape raises a practical and thrilling question. Could we ever find direct evidence of a neighboring reality? The answer may lie not in a telescope pointed at distant stars, but in the oldest light in the universe, a fossilized imprint from the dawn of time. We must return to the vision of eternal inflation, where our universe is one bubble in a frothing sea of spacetime. In this model, these bubbles are not static. They expand, drift, and on rare, momentous occasions, they might even meet. If our infant universe, still hot and dense in its first moments, brushed against the boundary of another cosmic bubble, that unimaginable encounter would have sent ripples through the very fabric of our newborn cosmos. The echoes of that primordial meeting could still be visible today, etched into the cosmic microwave background radiation. This faint, uniform glow that fills the sky is the cooled remnant of the Big Bang's fireball, a snapshot of the universe when it was only 380,000 years old. It is the ultimate cosmic photograph, and researchers have been meticulously scanning it for any sign of a distinctive mark, a subtle imprint left by an encounter with another universe. What would such a signature look like? Theorists suggest it might appear as a distinct circular pattern imprinted on the temperature map of this ancient light. The reason is geometry. Imagine two soap bubbles gently touching. The region of contact is a circle. A meeting between two inflating spacetime bubbles would create a similar circular boundary. The immense energy released at that boundary would have slightly heated or cooled the plasma within our early universe in a very specific, ring-shaped region. As the universe expanded and cooled, that ring would have been stretched across the sky, preserved in the subtle temperature variations we can still detect. It would be a cosmic bullseye, a target from another realm. For over a decade, teams of scientists have used data from satellites like Planck to search for these unusual concentric circles or temperature patterns that stand apart from standard predictions. They employ sophisticated algorithms to scan the entire sky, looking for signals that stand out against the random quantum fluctuations that seeded all the galaxies we see today. The search is extraordinarily difficult, akin to looking for a single, faint watermark on a vast and textured canvas. The signal, if it exists, would be incredibly subtle, woven into the noise from our own galaxy and the complex physics of the early universe itself. While a few intriguing candidate features have been noted, no definitive and universally accepted imprint has been confirmed. Yet the search continues, driven by the profound implications of a potential discovery. Finding such a fingerprint would be a scientific revolution on par with the discovery of the cosmic microwave background itself. It would provide the first tangible, observational evidence that our universe is not alone. It would transform the multiverse from a compelling theoretical idea into a feature of the physical world, moving it squarely into the domain of observational astronomy. We would have a data point from outside our cosmic horizon. That single, faint circle on the sky would tell us that the greater cosmos is not just vast but populous, filled with other universes born from the same eternal process. It would offer a glimpse into the architecture of a grander reality, suggesting that these bubble worlds are not forever isolated but can interact in their fiery infancy. More than that, it would provide a crucial anchor point for our deepest theories, guiding physicists toward a clearer description of the underlying mechanics of everything. This ongoing search for cosmic fingerprints is a testament to science's most powerful drive, the relentless pursuit of evidence. It reminds us that even our most expansive ideas about reality must, in the end, face the clear light of observation. This search for evidence in the ancient sky is a quest for a physical signature, a mark left by another universe in the fabric of our own. But there is another, radically different perspective on where other realities might exist, one that does not look outward to the cosmos, but inward to the very nature of information. It asks a startling question: could our universe itself be a constructed experience, one of countless digital worlds running on a super-advanced computer in some foundational reality? This modern twist, often called the simulation hypothesis, offers a profoundly different kind of multiverse, one built not from space-time or quantum fields, but from processed information. The core argument, popularized by philosopher Nick Bostrom, rests on a logical chain of possibilities. First, if a civilization reaches a highly advanced stage of technological maturity, it would likely possess immense computing power. Second, such a civilization might have an interest in running detailed simulations of its own history or of alternative realities, perhaps for research, entertainment, or cultural legacy. Third, if even a small fraction of such civilizations run many simulations, the number of simulated minds would vastly outnumber the minds in the original foundational reality. Therefore, statistically, it is more likely we are among the simulated beings than the original ones. This is not proof, but a probabilistic argument about our place in a potential digital landscape. The implications ripple out in fascinating ways. If our reality is a simulation, then other constructed universes would be running on the same or similar computational foundation. They would be parallel in a literal processing sense, like multiple programs operating on a cosmic server. The laws of physics we observe would not be fundamental truths of a base reality, but simply the rules of the simulation, the software code governing our local environment. Inconsistencies or simplifications in that code could potentially be detected, perhaps in the fine-grained behavior of particles or in slight statistical anomalies at the edges of our most precise experiments. Some thinkers have even proposed tests looking for evidence of a finite resolution to spacetime, or for conservation laws that are not perfectly upheld due to approximations in the calculation. This idea forces a deep philosophical reconsideration of what reality means. If we are in a simulation, does that make our experiences, our emotions, and the universe we explore any less meaningful? From our perspective inside the system, the answer is no. The constructed world is our only world. Its rules are our absolute laws. This digital multiverse intersects with traditional physics-based ideas in a thought-provoking way. The many worlds of quantum mechanics could be seen as the efficient processing of all possible outcomes within the simulation. The bubble universes of eternal inflation could be different simulation instances initialized with different parameters. It provides a modern, technological metaphor for ancient questions about perception and substance. While distinct from the multiverses born of cosmic inflation or quantum branching, the simulation hypothesis layers a new dimension onto our discussion. It suggests that the ultimate nature of coexisting realities might not be a question of cosmology alone, but of information science. Are we living in a cosmic accident, a statistical inevitability in an infinite physical landscape, or are we participants in a grand digital archive? Each possibility points toward a reality far stranger and more interconnected than our ancestors could have dreamed, challenging us to define what it means to truly exist in a cosmos that may be far more creative and far more prolific than we ever imagined. The ancient light of the cosmos and the logic of simulations offer external paths to other worlds, yet there is a frontier even more intimate, one that places us, the observer, at the very heart of the mystery. Where does consciousness fit in a multiverse? This question forces a meeting between physics and philosophy, between what happens and what is experienced. In a traditional view of quantum mechanics, the act of observation holds a unique power. A particle exists in a haze of possibilities until a conscious observer measures it, settling its state into a single, definite outcome. Here, consciousness is not a passive witness but an active participant in shaping reality. But this view creates a profound puzzle, the so-called hard problem of consciousness. How does subjective experience, the feeling of being, arise from the physical interactions of atoms and neurons? And why would such a feeling have the power to influence quantum systems? The many worlds interpretation offers a different, perhaps even stranger, resolution. If every quantum possibility branches into its own reality, then there is no special moment of selection. Every outcome is equally real. In this framework, consciousness does not select a single timeline, it simply travels along one. Your stream of awareness, the continuity of your experience, is like a thread weaving through one specific branch of the ever-splitting cosmic tree. At the moment of a quantum event, your conscious self does not choose, it divides. One version of you sees the electron on the left, another version sees it on the right. Both experiences are complete and real, but they are now forever separate. This suggests a startling possibility. There is no single you. There is a branching tree of selves, each following a different path of experience, all stemming from the same origin point. The you reading this sentence is just one thread in a vast tapestry of your own possible lives. This leads to theories like the quantum mind idea, which proposes that consciousness itself may be a quantum process occurring within the brain. If true, then the branching of the physical world and the branching of conscious experience would be intrinsically linked, two sides of the same coin. Your mind would not be a passive passenger on a branching universe, it would be an integral part of the branching mechanism itself. We are left with provocative, deeply personal questions. Are there other versions of you right now, aware of different outcomes from key moments in your life? Is there a version who took that different job, who said yes instead of no, who turned left instead of right? In a many worlds reality, the answer is not speculative fiction. It is a mathematical suggestion. Those other selves are as real as you are, each living a life with its own unique experiences, completely unaware of your specific path. This does not diminish your choices, it infinitely multiplies their reach. Every decision creates a new world where a different you lives with the results. This perspective transforms identity from a singular point into a probability cloud of selves. It challenges our deepest intuitions about self, memory, and destiny. We are not a static entity moving through time, but a constantly differentiating pattern of experience within an endlessly forking reality. The search for other universes, then, may ultimately be a search for the other parts of ourselves, the echoes of paths not taken that resonate in a cosmos where every story is told. The profound isolation of these cosmic domains seems absolute, a fundamental rule of the multiverse. Each universe, whether a quantum branch or an inflationary bubble, is sealed within its own causal horizon. No light, no signal, no particle can cross that ultimate divide. They are like ships in an endless ocean, sailing forever without sight or sound of one another. Yet some of the boldest extensions of our theories dare to ask, what if that isolation is not perfect? What if, under extraordinary circumstances, a whisper can pass between the worlds? String theory, with its landscape of curled-up dimensions, offers one tantalizing possibility for such a connection. In this framework, our entire four-dimensional universe might be a membrane floating in a higher dimensional space. Other universes could be other such membranes, parallel sheets of reality separated by a gap in these extra dimensions. While normally separate, these cosmic sheets could, in principle, move. A gentle vibration or a close pass between two of them could send ripples through each one. This theoretical leakage could manifest in our universe as a sudden, inexplicable influx of energy, a burst of particles with no apparent source, or even a subtle, persistent background hum in the fabric of spacetime. Some have even speculated that certain unexplained high-energy cosmic events could one day be interpreted through this lens, not as explosions from within our cosmos, but as distant echoes from a neighboring reality brushing against our own. More fundamentally, the very idea of a branching multiverse challenges our classical understanding of cause and effect. In our everyday world, causality is a clean, linear chain. One event leads to a specific, determined outcome, but in a quantum many-worlds reality, this chain unfolds into a spray of possibilities. A single cause does not have one effect, it has every possible effect, each realized in a newly created universe. From the perspective of the greater multiverse, the link between a specific cause and a specific effect is transformed. There is no single selection, only proliferation. Your decision to turn left at an intersection does not cause a single reality where you turn left. It is the moment that reality and a separate one where you turn right both spring into being. Causality, in this grand view, is not a thread but a tapestry woven from every conceivable connection. This reshapes how we think about fate, probability, and even history. In a single universe, the past is a fixed path leading to our present. In a multiverse, the past is a trunk that constantly splits, with countless presents existing simultaneously. There is no single historical timeline that must be, only an ever-widening fan of timelines that are. This does not make our local experience of cause and effect any less real or important. Within your branch, the chain remains logical and consistent. You turned left, and the consequences of that choice unfold around you. But from a broader perspective, your choice was not the reason the left-turning universe exists. It was the event that differentiated it from its right-turning sibling. The multiverse, therefore, presents us with two levels of causality, the local and the global, and they tell very different stories about the nature of reality. Understanding this isolation and the speculative cracks within it is essential. It tells us that if other worlds exist, they are not alternate destinations we can visit, but parallel narratives we can never read. Any potential interaction would be a ghostly, fundamental event, not a doorway. This very separation is what allows each universe to have its own stable laws and its own consistent history. It protects the integrity of our reality while hinting that we may be part of something unimaginably vast. A cosmic ensemble where every story is told in full, forever isolated, yet forever connected by the underlying mathematics that brought them all into being. These ideas of isolation and connection are not confined to physics journals. They have exploded into our collective imagination, reshaping the stories we tell about ourselves. The multiverse has become a dominant cultural force, a narrative playground where creators explore the deepest questions of choice, memory, and identity. In the Academy Award-winning film Everything Everywhere All at Once, the concept is not just a backdrop, it is the entire emotional landscape. The protagonist, Evelyn, does not travel to distant galaxies. She glimpses versions of herself in parallel lives, from a martial arts superstar to a woman with hot dogs for fingers. The scientific details are not the point. The film uses the multiverse as a brilliant metaphor for the overwhelming nature of modern life, for the paths we did not take, and ultimately, for the profound power of choosing to be present in one single, messy reality. It turns quantum branching into a story about family, love, and the choices that define us. Marvel comics and films have long woven alternate realities into their vast tapestry, from the dystopian world of Age of Ultron to the animated Spider-Verse. Here, the multiverse often serves as a mechanism for high-stakes conflict and renewal, but it also grapples with destiny. If there are infinite versions of a hero, what makes any one of them truly unique? These stories simplify the complex physics into accessible rules, like the idea of incursions where universes collide, but they tap into a genuine human curiosity. They allow us to ask, in a safe, fictional space, what our lives might look like if one key moment had unfolded differently. This cultural resonance is a powerful testament. It shows that the multiverse hypothesis connects with something far more fundamental than equations. It speaks to our universal experience of wondering about the road not taken. Every person at some point has looked back at a pivotal decision and pondered the ghost of a different life. Art takes this private feeling and gives it a cosmic stage, transforming personal reflection into a grand adventure across the landscape of possibility. By dramatizing these concepts, culture performs a vital service. It makes profound philosophical questions about identity and fate accessible to millions, inviting them to engage with ideas that might otherwise seem abstract or intimidating. There is a beautiful feedback loop at work here. Scientific speculation inspires artistic expression, and that art, in turn, fuels public fascination, which drives more people to wonder about the underlying science. While a physicist might see the many worlds interpretation as a solution to a measurement problem, a film goer might see it as a poignant reflection on the lives we could have lived. Both perspectives are valid and both enrich our understanding. The multiverse, in this sense, has transcended its origins. It is no longer just a hypothesis in cosmology or quantum mechanics. It has become a modern myth, a framework we use to make sense of our own finite lives against a backdrop of infinite possibility. It reminds us that our stories, however singular they feel, are part of a much larger, more creative, and more mysterious narrative still being written. If every possible version of you exists somewhere, then the very foundation of how we understand right and wrong begins to shimmer and shift. This idea of many worlds does not just rearrange the cosmos, it invites a deep re-examination of who we are and the meaning behind our decisions. In a reality where every path is walked, what happens to our sense of responsibility? Consider a person who makes a deeply harmful choice in one universe. Following the logic of branching realities, there must be another world where that same individual, influenced by different circumstances or a different moment of chance, becomes an example of generosity instead. Both share a common origin, a linked history up to a point, yet their paths turn in opposite directions. This presents a thoughtful challenge to long-held ideas about character, free will, and how we assign meaning to our actions. If every decision creates a realm where another choice is made, does that lessen the importance of any single one? Some perspectives suggest it could lead to a quiet unease, a sense that what we do might not hold weight because a different self is living another story. From this angle, the concept of many worlds might seem to offer a distant excuse, a way to glance away from accountability by noting another place where a better option was taken. But this view overlooks something essential about our own lived truth. From within your specific thread of experience, your choices feel absolute and their outcomes are deeply real. Though you reading this is the one who carries the weight of this particular life's decisions, its joys and its challenges, your awareness is not diluted across all possibilities. It is rooted here in this single stream of cause and effect. Your ethical duty is not to a vague collection of other selves, but to the immediate world and the people around you in this universe. This leads to another way of seeing things, one that finds not unease, but a curious comfort in the infinite tapestry. If all possibilities are realized, then no potential for kindness is ever truly lost. Every instance of bravery, every gesture of understanding, exists somewhere in the wider landscape of being. Your most hopeful self is not a mischance but a reality in another realm. This does not forgive the choices made in this one, but it can soften how we view our regrets. It suggests that while we must live with the consequences of our specific journey, the full spectrum of human potential is never wasted, only expressed across a broader canvas than we can see. In the end, this concept does not erase free will, it reframes its scope. Your will is not the power to choose one future for all that is, but the force that decides which specific future you, this unique point of awareness, will actually experience. You are both the author and the main character of a single, unchangeable story within an endless library. The significance of your actions is not lessened by the existence of other books. It is given its precise shape by the narrative you are writing line by line. This understanding brings the question of how we live well back from the cosmic scale to the human one. Our responsibility is not to the multitude of worlds, but to the singular, precious reality we are actively shaping with every decision we make. The existence of other stories does not relieve us of our part. It underscores the irreducible importance of the one we call home. This ultimate separation between worlds presents the central scientific challenge. How can we ever know if something truly exists if we can never see it, touch it, or receive a signal from it? The search for evidence of the multiverse is not a hunt for a direct photograph, but a meticulous investigation of our own universe, looking for clues that point to a larger, hidden architecture. We must become cosmic detectives, examining the evidence left behind from the earliest moments for any trace of another reality. The most promising avenue remains the search for imprints in the cosmic microwave background, the afterglow of the Big Bang. As discussed, an interaction with another bubble universe in our distant past could have left a distinct circular pattern, a subtle mark on this ancient light. While no definitive signature has been confirmed, the search grows ever more sophisticated. Future space observatories with unprecedented sensitivity will map this fossil radiation in finer detail than ever before, scanning for those subtle, telltale rings that current technology might miss. It is a patient, generational search, sifting through the static of the early universe for a whisper from beyond our horizon. Beyond this cosmic snapshot, we might find hints in the behavior of the fundamental forces. Some versions of string theory, which suggest a landscape of universes, also predict the existence of extra-spatial dimensions curled up at microscopic scales. While we cannot visit these dimensions, their presence could subtly influence how particles interact in our own. Experiments at massive particle accelerators like the Large Hadron Collider are not just searching for new particles, they are probing the energy frontiers where the effects of extra dimensions might become visible, perhaps as unexpected shifts of energy or peculiar statistical patterns in collision data. A confirmed detection would not prove the multiverse directly, but it would validate a key pillar of the theories that make such a landscape possible. Gravitational wave astronomy opens another window. These ripples in spacetime, first detected in 2015, are a new way to sense the universe. Future observatories in space will listen for gravitational waves from the most energetic events in the early cosmos. Some theories suggest that the phase transitions that created bubble universes in an inflating sea would have generated a unique, low-frequency hum of gravitational waves. Finding this specific background signature in the data would be powerful, indirect evidence for the process of eternal inflation itself, the very engine thought to generate a multiverse. The evidence we seek, therefore, is almost always indirect. We test the root theories like inflation or string theory to their limits. If they survive every experimental and observational challenge we can devise, and if they continue to elegantly explain the features of our own world, then their stunning implication, a reality of many worlds, gains credibility. It becomes the most natural conclusion of a successful framework. This shifts the perspective in a subtle way. We may never have a video feed from another universe, but we could reach a point where the simplest, most coherent explanation for everything we see within our universe is that it is just one member of a vast ensemble. The question then becomes not can we prove it, but can we afford to ignore the implications of our own best theories? The journey to an answer will be defined by increasingly precise observations, more powerful simulations, and perhaps a moment of brilliant insight that connects a tiny anomaly in a particle detector to the grand structure of all that is. Even the most expansive multiverse theories still begin with a physical substrate, some form of energy or spacetime that bubbles or branches into being. But what if we have been looking at it all backwards? What if the foundation of reality is not physical at all, but purely abstract? This is the startling proposition of the mathematical universe hypothesis, championed by physicist Max Tegmark. It pushes the idea of the multiverse to its ultimate, logical extreme. The hypothesis does not merely say that our universe is beautifully described by mathematics, which it is. It asserts something far more profound, that our physical reality is mathematics. In this view, the universe is not a machine that runs on math. It is a mathematical structure, and we are self-aware patterns within it. To grasp this, consider a simple geometric shape like a perfect cube. In our everyday world, we think of a cube as a physical object we can hold. But the mathematical idea of a cube, defined by points, lines, and angles in three-dimensional space, exists independently. It has properties, relationships between its vertices, a specific volume. The mathematical universe hypothesis suggests that this abstract structure does not just represent a possible object, it is a reality in and of itself. If a structure is mathematically consistent with no internal contradictions, then it exists in a full, physical sense. Our cosmos, with its particles, forces, and dimensions, would correspond to one particularly complex mathematical structure. A universe with 4 spatial dimensions instead of 3 would be another, equally real structure. A cosmos where gravity follows an inverse cube law instead of an inverse square law would be yet another. This leads to the ultimate ensemble. Every possible mathematical structure that can be coherently defined becomes a physical reality. This includes not just variations on our physics, but realms of existence far stranger, built from entirely different logical foundations. Some might be static and timeless, eternal patterns of information. Others might be dynamic, unfolding in ways we could barely comprehend. In this view, the reason we find mathematics so unreasonably effective at describing the universe is no longer a mystery. We are not discovering the laws of nature, we are discovering the properties of the mathematical structure we happen to inhabit. This idea dissolves the boundary between the map and the territory. It asks us to consider that the substance of reality, the stuff we think of as solid and tangible, might be an illusion born of our particular vantage point within the structure. Our sensations of matter, energy, and force are simply the way this specific mathematical pattern feels from the inside. This perspective pushes beyond the borders of traditional physics into deep philosophical territory. It challenges the very notion of what we mean by real. Is a mathematical structure existing in a Platonic realm of ideas any less real than the atoms in your hand if it can give rise to conscious observers who experience it as concrete? While this hypothesis is currently untestable in a conventional sense, it serves as a powerful conceptual mirror. It reflects our journey of understanding back at us, suggesting that our search for a theory of everything might ultimately be a search for the correct self-consistent mathematical object. It proposes that the multiverse is not just a collection of physical worlds, but the complete set of all logical possibilities, a cosmos of pure reason where every consistent story is not just possible, but necessarily true. The cosmic silence surrounding our planet is one of the most profound puzzles we have ever encountered. Our galaxy alone contains hundreds of billions of stars with countless planets orbiting them. Given the sheer scale and age of the cosmos, you would expect the universe to be teeming with life, its signals buzzing across the void. Yet our telescopes hear nothing but the natural static of stars and gas. This contradiction is the heart of the Fermi paradox, famously captured by physicist Enrico Fermi's simple question, "Where is everybody?" The multiverse hypothesis adds a breathtaking new dimension to this mystery, suggesting we might be asking the question in the wrong place. If our universe is just one among a vast ensemble, then the statistics of life change dramatically. The fine-tuning we observe is not a universal rule, it is a local condition. In the landscape of eternal inflation or the mathematical multiverse, the vast majority of universes would have physical constants incompatible with the formation of stable atoms, long-lived stars, or complex chemistry. In those realms, the emergence of life is not just unlikely, it is physically impossible. Our universe, then, is not a typical place, it is an extraordinary outlier, a rare bubble where the cosmic lottery produced a winning ticket. In this view, the silence we experience is not a paradox, but an expectation. We are alone in our local cosmic neighborhood precisely because such neighborhoods capable of supporting complex observers are incredibly scarce in the greater meta-reality. But there is another, even more thought-provoking possibility. What if advanced civilizations are common, but they exist in realms we can never access? Consider the brain multiverse of string theory, where our four-dimensional universe is a sheet floating in a higher dimensional space. Another advanced civilization could be thriving on a parallel brain, separated from us by a gap in an extra dimension. To them, their universe is as vast and real as ours. They could have built galactic empires, developed transcendent technologies, and sent signals across their own cosmic web, all without a single photon ever crossing into our dimensional plane. They are not hiding, they are simply operating on a different channel of reality, one our instruments are fundamentally tuned out from. The cosmic silence, in this case, is not a sign of absence, but a limitation of our dimensional perception. This reshapes the famous Drake equation, the formula used to estimate the number of communicative civilizations in our galaxy. Traditionally, we plug in probabilities based on our single universe. But in a multiverse, we must add a prior term, the probability of existing in a universe where life is even possible at all. That single factor could be vanishingly small. The equation would then run not just across our galaxy, but across the cosmic ensemble, with the overwhelming majority of terms yielding zero. Our existence becomes the answer to the paradox. We are the evidence that such rare conditions can occur, and our solitude is the natural result of our specific, fortunate address. This does not necessarily mean we are utterly alone in the entire meta-reality. It simply means that finding another civilization within our own particular cosmic bubble might be like two specific grains of sand finding each other on two specific beaches in an endless archipelago. The distances, both spatial and dimensional, are too great. The multiverse, therefore, offers a spectrum of answers to the great silence. It could mean we are a rare oasis in a desert of sterile universes, or it could mean the cosmos is bustling with life, just not in our particular neighborhood of the greater reality. Either way, it transforms the Fermi paradox from a question about our universe into a clue about the architecture of everything that exists, suggesting that the answer to where everybody is might be, quite literally, everywhere else. The mirror shows a familiar face, but in the branching reality of the many worlds, that face looks back from countless different lives. Who are these other beings that share your origin, your memories up to a point, and perhaps your deepest potential? The question of personal identity in an infinite ensemble is not just a physics puzzle, it is a deeply personal journey into the nature of self. If every quantum decision spawns a new universe, then there exists a version of you who took that different job, who married a different person, who made a choice you still reflect upon. Their lives have unfolded from the same source as yours, like two rivers diverging from a single spring, but are they still you? Philosophy offers frameworks to grapple with this. One prominent view is psychological continuity. This suggests you are not a static object, but a pattern, a flowing stream of memories, beliefs, and intentions connected over time. The you of yesterday is linked to the you of today by a chain of conscious experience. In a branching universe, at the moment of a quantum split, two identical streams are created. For a fleeting instant, both versions share perfect psychological continuity with the past. But from that point forward, their experiences, and thus their memories, begin to differ. One stream remembers turning left at the intersection, the other remembers turning right. Their chains of consciousness are now separate. They are like identical twins born at the moment of the split, each with an equal claim to the heritage of the person they once were, but now destined to become unique individuals. Physics provides another perspective with the concept of a world line. In the four-dimensional block of spacetime, your life is not a point moving through time, but a long, twisting thread from birth to the present. In a single universe, that thread is singular. In the many worlds view, your world line is not a thread but a braid, constantly splitting into new strands with each quantum possibility. Each strand is a valid, unbroken path through the higher dimensional reality. So from a cosmic, outside perspective, all these versions are equally real parts of a single, complex structure that is the totality of you across the multiverse. But from the inside, from the viewpoint of one specific strand, you only experience one unbroken sequence of moments. You are riding a single rail on a vast, branching track. This leads to the heart of the matter. Are these other beings truly you, or are they something else? They are not you in the sense of sharing your present consciousness. You cannot feel what they feel or access their memories, yet they are not merely distant relatives either, for they originated from the same precise point in reality as you did. They are your closest possible counterparts, your ontological siblings. Perhaps the most accurate description is that they are other instances of your initial conditions, living out the consequences of different variables in the cosmic equation. They share your origin story, but they are writing their own sequels. What does this mean for how you view your own life and choices? It suggests that identity is both more fragile and more resilient than we thought. It is fragile because the solid, singular self we feel is, from a broader view, just one manifestation among many. Yet it is resilient because the core pattern of being that defines you is not lost in other branches. It is expressed in different ways. Your capacity for love, courage, or curiosity exists in other worlds, shaped by different circumstances. This does not make your specific journey any less meaningful. Your experience is the only one you will ever know firsthand. The existence of other versions does not dilute your story. It testifies to the profound creative potential embedded in the moment of your beginning. In a cosmos of endless branching paths, you are both uniquely here and endlessly echoed. a single note in a chord that resonates across the landscape of all possibility. Across the branching streams of identity and the silent cosmic seas, our journey has explored reality through the lens of physics and philosophy. Yet for billions of people across the globe, the deepest questions of existence are framed within spiritual and religious traditions. How does the vision of a limitless multiverse resonate with these ancient and enduring worldviews? The conversation is not one of simple conflict or easy agreement, but a rich and complex dialogue between different ways of seeking truth. Many theological perspectives find the multiverse to be a concept that amplifies rather than diminishes a sense of divine grandeur. If a creative source is understood as infinite and all-powerful, then bringing forth a single universe could be seen as a modest act. The conception of a vast, perhaps endless, ensemble of worlds speaks to a creativity and abundance that feels more aligned with such a boundless origin. In this view, the multiverse does not remove a creator from the picture, it expands the canvas upon which that creative force works. A single masterpiece is impressive, but an endless gallery of unique creations, each with its own laws and stories, reflects a majesty beyond human scale. Some faith traditions have long incorporated ideas of multiple realms or planes of existence within their mystical teachings. Concepts of heavenly domains or layered realities in various philosophies can be seen as a form of theological multiverse, describing a cosmos richer and more textured than the physical one we perceive. For other viewpoints, the scientific multiverse presents a thoughtful consideration for the idea of a uniquely special creation. If our universe is just one among a near-infinite number, its particular conditions, including the emergence of life and conscious observers, might be reinterpreted. What was once seen as a deliberate and fine-tuned design could be recast as one possibility within a vast cosmic landscape. This does not necessarily challenge the idea of a creative source, but it might reshape our understanding of the relationship between that source and its expression. The question becomes one of method and purpose. Does a creative force work through singular events, or through the unfolding of immense generative processes that naturally yield diverse outcomes? Some find this latter idea deeply resonant, seeing the laws of physics themselves and their potential to generate endless variety as a profound signature of a foundational intelligence. The dialogue becomes most fascinating where the language of science and the language of spirituality seem to describe similar landscapes with different vocabularies. The quantum many-worlds interpretation, where every possibility is realized, echoes certain philosophical ideas about the manifestation of potential into being. The inflationary bubble multiverse, with realms forever separated, parallels contemplative descriptions of distinct planes of existence that are ontologically real but beyond our ordinary reach. These parallels are not proofs, but they are intriguing points of contact, suggesting that the human mind, whether through mathematical intuition or spiritual contemplation, may be circling the same profound mysteries about the plurality of existence. Ultimately, this is not a debate with a winner or loser. It is a meeting of two profound human endeavors, the search for meaning and the search for mechanism. One explores purpose, value, and the nature of the sacred. The other explores process, structure, and the nature of physical law. The multiverse idea, by stretching our conception of reality to its outermost limits, invites both endeavors to stretch as well. It asks theology to consider a creation of unimaginable scale and diversity, and it asks science to remain humble about the ultimate nature of what its equations might describe. In this shared space of wonder, the most important outcome may not be a final answer, but a deeper, more respectful conversation about the breathtaking complexity of the cosmos we are all trying to understand. The ultimate cosmic treasury might not be hidden in the stars of our own universe, but locked away in realities we can never touch. This leads to a staggering thought experiment. one that stretches our understanding of resources and growth to the very edge. If other realms were somehow accessible, they would represent a reservoir of existence beyond all measure. Imagine a single bubble universe similar to our own, containing the energy equivalent of hundreds of billions of galaxies. Now imagine an endless number of such bubbles. The total energy, matter, and potentially habitable space would be without any limit, a resource base so vast it defies any human concept of scarcity. We can frame this mind-bending scale through the lens of the Kardashev scale, a way to classify civilizations by their energy use. A Type 1 civilization harnesses all the energy of its home planet. A Type 2 controls the entire output of its star. A Type 3, a galactic civilization, would command the energy of every star in its galaxy. But what comes next? In a multiverse, a truly transcendent culture might aspire to become Type 4, one that draws power from the entire ensemble of universes. Such a being would not just be a master of a single cosmic domain, but an architect of realities, potentially capable of stabilizing or even creating new universes within the greater landscape. Its projects would be the very shaping of spacetime and physical law, a form of engineering so profound it would be indistinguishable from cosmology itself. This speculative vision casts a new light on the Fermi paradox and the great cosmic silence. If such multiversal civilizations are possible, why do we see no evidence of their unimaginable activities in our own sky? One compelling answer is woven directly into the fabric of most multiverse models: profound and permanent isolation. Those other realms are not just far away, they are causally disconnected, separated by expanding voids that outrun light or by gaps in higher dimensions. The treasure vault is sealed with a lock for which no key exists. The ultimate resources are, by the fundamental rules of reality, forever out of reach. This suggests that even the most advanced intelligence, bound within its own universe, would face the same ultimate constraints we do, a cosmic speed limit that confines all endeavors to a single, local reality. This realization brings a powerful and humbling focus back to our own fragile oasis. If the multiverse is real but inaccessible, then our universe is not just one room in an infinite mansion, it is the only room we will ever inhabit. Every star, every planet, every atom within our cosmic horizon constitutes the entirety of our possible resource base. There is no backup universe, no escape hatch, no infinite well of energy to tap if we exhaust our own. The preciousness of our local reality becomes astronomically magnified. It transforms our perspective on stewardship, not just of our planet, but of our entire cosmic inheritance. The silence we hear may not be a sign of absence, but the sound of ultimate physical limits, a reminder that even in a cosmos of infinite possibilities, our story, and all its resources, is contained within the finite and beautiful bubble we call home. Probability is the language of prediction, the tool we use to navigate a world of uncertainty. Yet in a cosmos where every possible outcome is guaranteed to happen somewhere, the very meaning of probability begins to unravel. This is not just a philosophical puzzle, it is a profound technical challenge at the heart of the many worlds interpretation, one that physicists have considered for decades. In our everyday experience, we say an electron has a 70% chance of being detected in one location and a 30% chance in another. Quantum mechanics provides these numbers through a mathematical rule called the Born rule. But if the many worlds view is correct, and the universe simply branches to accommodate both outcomes, then both outcomes become fully realized in their respective branches. So what does it mean to say one was more likely than the other? How do we recover the familiar, probabilistic world we actually observe from a foundation of deterministic branching? The question is to explain why you, as a conscious observer, should expect to find yourself in one branch over another with a predictable frequency. If there are simply two new universes, one with the electron on the left and one with it on the right, it seems you should be just as likely to end up in either one. That would lead to a prediction of 50-50 odds, which contradicts the 70-30 prediction of quantum mechanics. This is the core of the problem. To make the many worlds framework complete, it must not only describe branching, but also explain why we perceive some branches as being more common than others. It must derive the born rule from within the theory itself, not simply assume it. Physicists like David Deutsch have approached this by considering the perspective of an observer who will undergo many identical quantum experiments. In a vast branching tree of realities, there will be many more branches that contain sequences of results matching the 70-30 statistics than branches that contain highly skewed results. The idea is that your stream of consciousness is more likely to follow a path through the multiverse that looks statistically normal from the inside. It is a subtle argument that ties probability to the sheer number of similar worlds in the branching structure. The mathematics aims to show that you are overwhelmingly more likely to find yourself experiencing the world where the born rule holds true, even though every other possible sequence of results also exists somewhere. This technical work is more than an academic exercise. It reveals the immense challenge of constructing a coherent theory of everything. A successful framework must not only describe the fundamental machinery of reality, it must also account for our subjective experience of that reality, including our perception of chance. The effort to ground probability in a many-worlds reality forces a deep reconciliation between the objective, branching cosmos and the subjective, singular viewpoint of the observer within it. It asks whether likelihood is a fundamental feature of the universe, or an emergent feeling that arises from our specific location within an infinite tapestry of certainty. The ongoing work to solve this problem is a testament to the rigor of the scientific pursuit, ensuring that even our most breathtaking ideas about the cosmos remain accountable to the predictable, probabilistic world we all call home. The multiverse offers more than answers. It provides an infinite canvas for the human imagination. This idea has moved from the pages of physics to become a vibrant muse, inspiring creators across every medium to explore realities unbound by a single story. For artists, the concept is a visual revolution. Painters and digital creators craft stunning works that depict the moment of cosmic branching, where a single scene unfolds into a kaleidoscope of possibilities. You might see a portrait where a face reveals multiple expressions, or a cityscape where every window shows a different season or era, each pane a glimpse into a parallel street. These works make the abstract tangible, allowing us to visually wander through the branching corridors of what could be. Music, too, finds profound expression in these themes. Composers create symphonies and electronic soundscapes that embody the idea of simultaneity. A melody might gently separate into harmonious counterpoints, each representing a different emotional path, or a piece could layer complementary rhythms to evoke the feeling of multiple timelines unfolding together. The very structure of a musical composition, with its themes, variations, and returns, mirrors the concept of a central motif branching into endless variations, all connected by a common origin. It is sound giving form to the notion that every choice creates a new harmony somewhere in the cosmic chorus. Literature has long been a home for exploring alternate paths, but the multiverse framework gives these explorations a new philosophical depth. Modern novels and stories use layered narratives not as a simple device, but as a core structural principle to investigate identity and consequence. A character might encounter reflections of themselves from other branches, prompting a contemplation of paths not chosen. These narratives free storytelling from the constraint of a single timeline, allowing an author to hold multiple truths at once, showing how a single person contains multitudes of potential selves. This creative freedom does more than entertain. It reflects our own world's beautiful complexities back at us with startling clarity. By playing with infinite what-if scenarios, artists hold up a mirror to our own reality's nuances, joys, and interconnected nature. A story about a world where a historical moment unfolded differently can make us see the unique shape of our own present in a new light. A painting of diverging paths highlights the singular beauty of our own journey. This creative explosion is a testament to the concept's power. It is not a distant scientific idea, but a wellspring of wonder that validates our deepest human impulse to dream, to question, and to envision every shade of possibility. In the hands of creators, the multiverse becomes a tool for understanding, allowing us to imagine for a moment another perspective in a world that is, and also in a world that might have been. The frontier of this idea is not a static line on a map, but a horizon that recedes as we approach it. Our understanding of the multiverse will be forged in the coming decades by a powerful alliance of three forces: colossal machines that probe the fabric of space, eyes in the sky that peer back to the beginning, and the silent, relentless power of pure thought. The first place we will look is deep underground, within tunnels like those housing the Large Hadron Collider. Future particle accelerators, magnitudes more powerful, will push matter to energies that recreate conditions a fraction of a second after the Big Bang. In these microscopic fireballs, physicists will hunt for more than new particles. They will search for subtle anomalies in the way energy and momentum are distributed, tiny statistical whispers that could be the first evidence of extra-spatial dimensions curling away from our perception. A confirmed signature here would not just add a new particle to a chart. It would crack open a door to the higher dimensional architecture that string theory suggests could house a landscape of parallel realities. Above the atmosphere, a new generation of space observatories is being designed with the explicit goal of reading the cosmic microwave background like a profound historical record. Missions planned for the coming years will possess sensitivity so profound they could detect temperature variations 1,000,000 times fainter than those currently mapped. They will scan the ancient sky for elusive circular patterns, potential imprints from a long-ago encounter with another cosmic bubble, but their search extends beyond specific shapes. They will analyze the polarization of this ancient light, looking for the unique swirls imprinted by primordial gravitational waves, the ripples from the inflationary sea itself. Finding this signal would be like hearing the echo of the engine that may have spawned our universe and countless others. Alongside these physical instruments, theorists are engaged in a different kind of exploration, running vast and complex computer simulations of the early universe. These are not video games, but rigorous mathematical experiments that model how quantum fluctuations during inflation could stretch into the seeds of galaxies, and how bubble universes might form and interact in a meta-cosmic foam. By comparing the statistical fingerprints from these simulations with the exquisitely detailed data from new telescopes, we can test which models of inflation, if any, match our reality. This work refines our questions, telling us precisely what to look for in the noise of the cosmos. Theoretical work also continues on the deepest puzzles, like deriving the rules of probability from the branching many worlds, or finding a way to select a unique vacuum from string theory's vast landscape. The path forward demands this synergy, a constant conversation between the boldness of theory and the discipline of observation. It requires a readiness to accept that the answers we seek may not fit within our current intuition, that the ultimate nature of reality could be a form of strangeness we are only beginning to learn how to see. The next chapter will not be written by a single discovery, but by the patient, collective effort to listen to the universe with ever more refined ears, and to dare to interpret what it is trying to tell us about the company it may keep. The elegance of these ideas can feel like a gravitational pull, drawing us toward a breathtaking new reality. Yet the very heart of science is not a leap of faith, but a measured step back into the light of critical scrutiny. For all its mathematical beauty and philosophical resonance, we must acknowledge a simple truth. The multiverse hypothesis, in all its forms, remains without a single piece of direct, irrefutable evidence. It is a magnificent inference, a stunning implication drawn from theories we have good reason to trust, but an inference all the same. We see the shadow, but we have not yet touched the object casting it. The pillars we have explored, from quantum branching to inflationary bubbles, are built upon robust frameworks. Cosmic inflation elegantly explains the large-scale structure of our universe. Quantum mechanics makes predictions of astonishing precision, yet the step from these successful theories to the existence of countless other worlds is a significant one. It is a logical and consistent extension, but one that currently resides beyond the reach of direct observation. We test inflation by its fingerprints on our cosmic microwave background. We test quantum mechanics in our laboratories. The multiverse itself, however, is the proposed consequence of those tests passing, not the thing being tested directly. This places it in a fascinating space at the very edge of empirical science. This is not a shortcoming of the idea, but a vital reminder of how science truly works. The scientific method thrives on healthy skepticism, on the relentless demand for evidence. It is a process designed to protect us from the seduction of stories, no matter how elegant, that may not correspond to physical reality. To treat the multiverse as an established fact would be to abandon the very discipline that led us to consider it in the first place. Its true power may not be as a final answer, but as a profound question. It acts as a lens that forces us to re-examine the foundations of everything we think we know about existence, causality, and our own place in the cosmos. It expands the playing field of possibility, challenging us to devise new ways to seek evidence, to imagine tests we have not yet conceived. The journey of discovery, with all its doubt and wonder, is the story. Each path we have explored arrives at the same stunning destination. Quantum branching, eternal inflation, and string theory's landscape are not competing ideas, but different windows into a single, breathtaking vista. They may even be describing distinct layers of a grand, nested reality, like different floors of an infinite cosmic library. On the ground floor, the many worlds of quantum mechanics constantly splits our timeline into new branches, creating a multiverse of alternate histories. One floor up, the engine of eternal inflation spawns entire cosmic bubbles, each with its own unchangeable laws of physics, a multiverse of alternate settings. And in the highest conceptual attic, the mathematical universe hypothesis suggests every coherent structure simply is, implying a multiverse of all logical possibilities. These are not separate mansions, but interconnected wings of the same impossible estate. Think of it as a cosmic tree. The trunk represents the initial conditions of our reality. As it grows upward through time, it constantly splits into smaller branches, the quantum many worlds where every choice plays out. But this entire tree, trunk, and all its branching foliage is itself just one plant in an endless forest, where each tree is a bubble universe born from the same inflationary soil. And that entire forest exists within a garden of all conceivable landscapes. Each model operates at a different scale, from the subatomic to the cosmic to the purely logical, yet they harmonize into a single, profound theme. Plurality is a fundamental feature of existence. This convergence is not an accident. It reveals a deep pattern in our quest to understand reality. Whenever we push our theories to their logical extremes, to explain the quantum measurement problem or the flatness of the cosmos or the unification of forces, the mathematics gently, persistently, points beyond the horizon of a single universe. The idea of a solitary cosmos begins to feel like an arbitrary limit, a constraint our most successful frameworks no longer require. The multiverse, in its various forms, emerges not as a wild speculation, but as the most natural outcome of taking these theories seriously. It is the universe's way of telling us that our local reality, for all its majesty, is not the whole story. We are left with a coherent, if humbling, picture. Our home is likely not a lonely island in a void, but a vibrant neighborhood in a metropolis of realities. Some of our neighbors are eerily familiar, differing only in a single quantum event. Others are utterly alien, built from different numbers of dimensions or forces we cannot fathom. And still others may be pure patterns of information, existing in a realm of abstract truth. This synthesized view does not answer every question, but it provides a powerful framework for asking better ones. It suggests that the ultimate nature of reality is not singular, but prolific, a creative engine that generates not just stars and galaxies, but entire realms of being. The silence of our night sky is not the silence of an empty house, but the quiet between the walls of a vast and crowded cathedral, where every possible form of existence has its own chapel, forever echoing with the music of its own unique laws. Our exploration ends not with a final answer, but with a new beginning. The cosmos we once thought contained everything may be just the first page of an endless book. Across quantum branches, inflationary bubbles, and mathematical landscapes, a consistent theme emerges. Reality is not a singular event, but a creative process. While we may never receive a postcard from another universe, the very structure of our own world whispers of a grander architecture, a meta-reality where infinite variations on existence play out in parallel. This idea transforms from a speculative hypothesis into a profound lens through which we view everything, from the spin of an electron to the vast silence between galaxies. Whether this vision feels inspiring or unsettling is a deeply personal reflection. It can make our individual lives seem vanishingly small against an infinite backdrop, or it can imbue them with a strange new significance as the unique expression of one path through an ocean of possibility. It challenges the solidity of our identity, suggesting we are each a thread in a tapestry of selves. It pushes the boundaries of science, demanding we reconcile our need for testable evidence with the stunning implications of our most successful theories. Ultimately, the multiverse hypothesis is less about proving other worlds exist and more about understanding what the mere possibility of their existence reveals about our own. The journey to comprehend our place in this grand scheme has only just started. Every new observation of the cosmic microwave background, every experiment in a particle collider, and every breakthrough in theoretical physics adds another piece to this magnificent, evolving puzzle. The greatest discovery may not be finding another universe, but finally understanding the true, breathtaking nature of the one we call home. If this glimpse into the infinite has sparked your curiosity, consider subscribing for more deep dives into the mysteries of space. We would love to hear your thoughts on parallel realities in the comments below.